Hey everybody, in this video we are going to talk about similar solids as well as the area ratio and volume ratio of similar solids. So similar solids are two solids of the same type, which would mean if one's a rectangular prism, the other has to be a rectangular prism, with equal ratios of corresponding linear measures. Measures such as heights or radii. Okay, so for our first question here, we want to determine whether either of these two solids, A or B, is similar to this one here at the right. Now, if they are similar, then the ratio of all corresponding parts will be equal. So I'll do 8 to 4. That should be equal as 4 to 2. And that should also be equal to 2 to 2. 8 over 4, that's 2 over 1. 4 over 2 is 2 over 1. And 2 over 2 is 1 over 1. And that last one is not equal to the others. So no, A here is not similar to this figure. How about B? So we've got 6 is to 4. As 3 is to 2, as 3 is to 2. Now 6 over 4, 2 goes into both of those, 6 and 4, 3 times and 2 times. So we get an extended ratio of 3 to 2 equals 3 to 2 equals 3 to 2. Those are all the same, and that means that these two figures are indeed similar. Okay, so let's determine whether these are similar. So we have 12 is to 9, as 16 is to 12, as 4 is to 3. Okay, so let's simplify all three ratios. So 12 over 9, 3 goes into both of those 4 times and 3 times. 16 and 12, 4 goes into both of these 4 times and 3 times. And we have 4 over 3 equals 4 over 3 equals 4 over 3. So are these similar? Yes, because all three ratios are the same. Okay, how about these two cones? Let's do height over height, radius over radius. So we have 15 is to 10, as 10 is to 5. Okay, so 15 and 10, 5 goes into both of those 3 times and 2 times. And 10 and 5, 5 goes into both of those 2 times and 1 time. These are not the same, so no, these are not similar. If two similar solids have a scale factor of A to B, so a scale factor is the same as a similarity ratio, and right here I've got a scale factor of 4 over 3 because the ratio is 4 to 3. Up here we had a ratio of 3 to 2, so the scale factor is 3 over 2. Here the scale factor is 4 over 3. Okay, so if we have a scale factor of A to B, or A over B, then corresponding areas have a ratio of A squared to B squared, and corresponding volumes have a ratio of A cubed to B cubed. Okay, so let's use that information here on this next page. These pyramids are similar. Pyramid P has a volume of 1,000 cubic inches, and Pyramid Q has a volume of 216 cubic inches. So here we have a volume of 1,000 inches cubed, and here we have a volume of 216 inches cubed. We want to find the scale factor. Okay, so there are 3 different ratios. There's the similarity ratio, the area ratio, and the volume ratio. Okay, so the similarity ratio, that is the scale factor. That's what we're looking for here. Okay, what we have is volumes, and we can make a volume ratio out of that. And we want this to be pyramid P to pyramid Q. So that means 1,000 over 216. That is the volume ratio. Okay, so remember the similarity ratio is A to B, so that's first power. Area ratio is second power, A squared to B squared. And the volume ratio is third power, A cubed to B cubed. So if we want to go from the volume ratio to the similarity ratio, then what we're going to have to do is take a cubed root. Okay, so in order to get this volume ratio into a similarity ratio or a scale factor, we need to do the cubed root of 1,000 over 216. Okay, so in our calculator, we'll do each individually. So we've got the cubed root, so we're going to use this button right here. So we'll type 3 and then that x root, so second and x root. So now we're doing the cubed root of 1,000, and that is 10. Okay, so the numerator in the similarity ratio is 10. And then again for the denominator, second and then x root. So we get the cubed root of 216, and that is 6. So 10 over 6 is our similarity ratio or our scale factor. Now we can simplify that, so we should do so. 10 and 6 are both divisible by 2, 5 times and 3 times. And there is our similarity ratio, also called the scale factor. Next, we have two cylinders with volumes of 5,832 cubic inches and 6,859 inches. What is the ratio of the surface area of the smaller cylinder to the surface area of the larger cylinder? So we have our three ratios, the similarity ratio, the area ratio, and the volume ratio. And from this, we can get the volume ratio because we have volumes. Okay, now it says smaller cylinder to larger cylinder. So we're going to put smaller over larger. So the volume ratio, smaller over larger, is 5,832 over 6,859. Okay, now we need to turn that into an area ratio. The first thing we have to do is turn it into a similarity ratio by taking the cubed root. So we've got the cubed root of 5,832 over 6,859. So the cubed root of 5,832 is 18. And for 6,859, we have 19. So the similarity ratio, or the scale factor, is 18 over 19. Okay, now we can turn that into an area ratio by raising it to the second power. Okay, so the area ratio is a squared over b squared. So here's a and b. Here's a cubed and b cubed. We turned that into a and b. Now a squared over b squared. Okay, so we're going to take that 18 over 19 and square it. And that will give us the ratio of the surface areas. So we have 18 squared, 324, over 19 squared, 361. And that is the ratio of the surface areas. Okay, we're going to do one more here. If the volume ratio is 81 over 24, what is the area ratio? So we've got the similarity ratio, the area ratio, which is what we are looking for, and the volume ratio, which is what we are starting with. So we have a volume ratio of 81 over 24. We need to turn that into the similarity ratio, and we can do that by taking the cubed root. So the cubed root of 81 over 24. So the cubed root of 81 is a decimal. Now, in order to fix that, it looks like what I should do is actually simplify 81 over 24. So what goes into 81 and 24? I believe 3 goes into both. So let's do 81 divided by 3 and 24 divided by 3. And we're going to have 27 over 8. Okay, so the volume ratio is 27 over 8. So we're really finding the cubed root of 27 over 8. So let's try that and see if we get whole numbers. So the cubed root of 27 is 3. And the cubed root of 8 is 2. So 3 over 2 is the similarity ratio. So that's a over b. So I started with a cubed over b cubed. I took a cubed root to get a over b. Now I will square that to get a squared over b squared, and that is going to be the area ratio. Okay, so I can probably do that without a calculator. So I've got 3 over 2 squared. 3 squared is 9. 2 squared is 4. 9 over 4 is the area ratio.